This is a view of a transverse fracture of the radius. An uncontoured plate has been fixed with reduction forceps to the two fragments of the radius. The first screw will be inserted in one end of the plate using the universal drill guide in the neutral position, thus placing the screw in the center of the plate hole. The 2.5 millimeter drill bit is used to create the hole in the bone. The depth gauge determines the screw length. The 3.5 millimeter tap placed through the drill guide cuts the thread in both cortices. The appropriate length 3.5 millimeter screw is inserted. Another screw is inserted at the other end of the plate in the same manner. Axial alignment of one fragment is secured by inserting a second neutral screw in this fragment. Compression will now be achieved by using the universal drill guide in the eccentric position. The hole is measured and tapped as before, and the screw is inserted. The clamp is removed. As the screw head engages the gliding slope of the plate hole, it pushes the plate to the left. Compression is created at the fracture line in the cortex underneath the plate. It has to be noted that a gap remains in the far cortex. The plate is removed and a bending template is contoured to the cranial surface of the radius. The plate is bent between the plate holes with the bending pliers. Slightly over-bending the plate at the fracture site will pre-stress the plate. The over-bending can be observed when the plate is compared to the bending template. The screws are reinserted into the holes in the order they were originally placed. It is clear that with the plate being pre-stressed, the eccentrically positioned screw provides compression along the entire fracture line. The remaining screws are inserted neutrally. After all the screws are in place, they should be retightened. The plate hole design allows the universal drill guide to be used in any plate hole once the fragments are axially aligned.